بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 7.2, which is about trigonometric integral. So we learned in this section how to find the integral of sine to the power mx times cosine to the power nx dx. And we can deal with this integral because of the important relation between sine square and cosine square. Sine square x plus cosine square x is always 1. So if one of the powers is odd, for example, here the power of sine is odd, so immediately we take u as cosine, and then we find du. Du is negative sine x dx. That's the derivative of cosine. And then we arrange this integral in a way that we can use this substitution. So I start by taking one sine of the three sines we have, or one sine of sine cube, and put it beside the dx. Okay, and then I still have sine square x. Now sine square times sine will give you sine cube, and I also have cosine square. So I prepared the du, and now I should take cosine as u, but there is sine in the question. So this sign doesn't suit me because I cannot change it to u. So I must change it to cosine using this formula. So sine square from this formula is 1 minus cosine square. So I can write sine square as 1 minus cosine square, and this cosine square is there, and I have sine x, or I can write it negative sine x dx. I multiplied by negative, so I multiply by negative outside. And now the integral is ready to be changed to u. So any cosine, I'll call it u. So I'll have 1 minus u square because of cosine square. And I have cosine square outside, so this is also u square. And then negative sine x dx is just du. And now you continue easily because you can expand. U square times 1 is u square, minus u square times u square, that's u to the power 4. And now the integral of u square is u cube over 3, and minus times minus is plus, and the integral of u to the power 4 is u to the power 5 over 5 plus c. And now you can write u again as cosine because the substitution was u equals cosine. So the answer would be negative 1 over 3 cosine cube x plus 1 over 5 cosine to the power 5x plus c. This is the integral. Now, if one of them is odd, we will always do this method. So here we have sine to the power 5, cosine to the power 9. I'll choose the smaller power, so I'll deal with sine. Sine has an odd power, so I'll let u equals cosine. And then find du, that's negative sine x dx. And I arrange the integral. So I have integral of one of the sines, I take it here with the dx. And cosine is there, I need cosine to change it to u. And sine to the power 4 will be there. So sine to the power 4, I can write it sine square, which is 1 minus cosine square to the power 2. And now the integral is ready to be changed to u. But let us also change the limits of the integral. So if x is 0, cosine 0 is 1, so u is 1. And if x is pi over 2, cosine pi over 2 is 0, so u is 0. So this integral, when it's changed to u, would be 0 will be 1, pi over 2 would be 0, cosine 9 would be u to the power 9, 1 minus cosine square would be u square to the power 2. I need negative, okay? So I multiply by negative, and negative sine x dx is just du. And now let us evaluate this integral. Before evaluating, I need to expand 1 minus u squared to the power 2. So it's 1 minus 2 u squared plus u to the power 4 du. And then I need to multiply by u to the power 9. So I'll have u to the power 9 minus 2 u to the power 11 plus u to the power 9 plus 4 is 13 times du. And I'll have u to the power 10 over 10 from 1 to 0 minus 2 u to the power 12 over 12 from 1 to 0 and plus u to the power 14 over 14 from 1 to 0. So I have 1 over 10 and 0 to the power 10 is 0 minus 1 to the power 10, so I have minus 1, okay? And here I have negative 2 over 12, that's negative 1 over 6, and 0 to the power 12 is 0, minus 1 to the power 12, so that's again minus 1, and I have here plus 1 over 14, my times minus 1. Why it's minus 1? Because 0 to the power 14 minus 1 to the power 14. So the minus is outside, okay? So I'll have always minus 1 here. So the answer would be negative 1 over 10, positive 1 over 6, negative 1 over 14, and you can find the calculator and write the answers. You can add these three fractions, and the answer is really a very small number, but anyway, let us write it. It's negative 1 over 210. And you can check your answer. That's your answer by calculator if you like. You put this in the calculator and see whether the answer is negative 1 over 210 or not. What do we have now? We have cosine to the power 3. So if you have cosine to the power 3, you take u as sine. But here I have t to the power 2, so that's no problem. I'll take it. I'll take u sine t to the power 2. Find du. The derivative of sine is cosine times the derivative, chain rule, times the derivative of this function, t over 2. The derivative of t over 2 is half, because t over 2 is just half times t. So the derivative of t over 2 is just half. Okay, so now, of course, multiplied by dt. So this is my du, and I need to rewrite this integral. I need half cosine t over 2 dt here. This means I took one of these cosines, so I have left with cosine square. Okay, and also I have sine square. And I multiply it by half, so outside I will multiply by 2. Now sine would be taken as u, but cosine I don't need it, so I have to change it to sine. So I know that cosine square t over 2 would be equal to 1 minus sine square t over 2. Okay, so I can write it 2 times 1 minus sine square t over 2 times sine square t over 2 times half cosine t over 2 dt, and I am ready now to change the question to u. So 1 minus sine t over 2 is u, so this is u square. Sine t over 2 is u, so this is again u square, and this is just du. And I believe you can continue now like we did in the previous two questions. Now, if neither sine nor cosine has an odd power like this, sine square or cosine square, then we have to use a formula to change sine square to cosine. The formula says sine square theta is 1 minus cosine 2 theta over 2. We need to memorize this formula if we don't know how to derive it and use it. So we will have integral from 0 to pi over 4 1 minus, but this is sine square 2 theta. So when we have theta, we multiply it by 2. So when we have 2 theta, it would be cosine 4 theta over 2 d theta. So this question will be transferred to this question. 2, I can take the 2 outside as half, and I have 1 minus cosine 4 theta d theta, and the integral is easy. Integral of 1 is theta from 0 to pi over 4 minus integral cosine sine, and I divide by the derivative of 4 theta, which is 4 from 0 to pi over 4. So there is a half, and pi over 4 minus 0 is just pi over 4 minus pi over 4. 4 times pi over 4 is pi. Sine pi is 0. So minus sine 0 is also 0. So there is nothing here because sine pi of pi is 0 and sine 0 is 0. So the final answer is just pi over 8. And you can again put this in the calculator and check that the answer is correct. Cosine to the power 4 is similar to sine to the power 2, but we have power 4. And for cosine, the formula is 1 plus, not minus. So whenever you have cosine square or 4 or to the power 6, any even power, you have to use this formula immediately. So it is integral from 0 to pi. And cosine to the power 4 would be cosine squared to the power 2. So it's 1 plus cosine, and this is 2t, so it would be 4t over 2. This is cosine square. I raise it to the power 2, so it would be cosine to the power 4. And now I can take this 2 out, but it's squared. And I can expand the numerator. So 1 square is 1. Cosine times 1 times 2 is 2 cosine. And plus cosine square for t dt. Well, I can find the integral of 1 cosine, but cosine square, I need again to change it using this formula. So I will have 1 over 4 integral from 0 to pi 1 plus 2 cosine 40. And let me change cosine square 40 outside. Okay. So what would be cosine square 40? It would be 1 plus cosine 2 times 4. So it's 8t over 2. So this is cosine square 40. It is in fact 1 over 2 plus cosine 8t over 2. So I will write the integral finally like this. 1 plus half, 3 over 2, plus 2 cosine 4t, plus half cosine 8t, and I am now ready to find the integral. So integral of 3 over 2 is 3 over 2t or pi minus 0. So it's pi plus 2. Integral of cosine is sine 4t over 4 from 0 to pi plus half. Integral of cosine 8t is sine over 8 from 0 to pi. So I'll have 1 over 4, 3 pi over 2. 2 over 4 is half. Sine 4 pi is 0. Minus sine 0, that's 0 times half. So this term will be cancelled. What about this one? Sine 8 pi is 0 minus sine 0. So that's excellent. So the answer would be 3 pi over 8. That's the answer. What do we have here? Power of sine is 2, power of cosine is 2. There is no odd power. So I will change both using the formula. So sine square is 1 plus, I can write it cosine plus of course, but let me 1 plus, no, sine square is 1 minus, not 1 plus. 1 minus cosine 2 theta over 2, and cosine square is 1 plus cosine 2 theta over 2. So we just wrote the definition or the formula of sine square and cosine square. Okay. 2 times 2 is 4 and I can take it out. Well, 1 minus cosine 2 theta times 1 plus cosine 2 theta, difference of two squares, u minus v times u plus v will give you u square minus v square. I have no problem with 1, but I have problem with cosine square. I need to change it again. 1 plus this time cosine 4 theta, because this is 2 theta, I multiply by 2 over 2. Notice that this is 1 over 2. 1 minus 1 over 2 is half. Minus cosine 4 theta over 2. Integral of half is half times half x, or half theta, or you replace theta by pi over 2 minus 0, minus half. Integral of cosine 4 theta is sine 4 theta over 4 from 0 to pi over 2. Okay. Sine 4 pi over 2 is sine 2 pi. That's 0. And sine 0 is 0. So as in the previous two examples, we have the answer would be pi over 4 times 2 times 2, that's 16. So this would be the answer, and the other term would be 0. What to do here? I have no 2 minus sine to the power 2. Well, I need to expand. Square of a binomial. 2 square is 4. Minus 2 times 2, so that's 4 sine theta plus sine square theta. Well, I can integrate 4 sine theta, but sine square, I have to write it as 1 minus cosine 2 theta over 2, or 1 over 2 minus half cosine 2 theta. But there is a 4 here. So this 4 plus this half would be 9 over 2 minus 4 sine theta minus half cosine 2 theta d theta. And I believe you can continue as we did in the previous questions and check your solution at the end. What do we have here? We have sine to the power 3, odd power. But this is square root. Don't worry about it. Just concentrate on the third power of sine. So we said that immediately we take u cosine and find du, negative sine x dx. So how to arrange this integral? I have square roots. Well, everything is in terms of theta. So this is theta, theta, theta. And sine cube, I need sine theta to be here with the d theta, and I will still have sine square theta because I already have sine cube. Now cosine is okay with me, but I need to change sine to cosine. So I will have square root of cosine times 1 minus cosine square theta and times negative sine theta d theta, and I'll put the minus outside. So I will have negative integral, and now I can change everything to u. This is square root of u, 1 minus u square, and this is du. And there is no problem here, square root of u minus u to the power 2 plus half, which is 5 over 2, and you continue and find the answer. Also, we have power cosine odd. The power of cosine is odd. So immediately we let u equals sine t. And du would be cosine t dt. So I need cosine beside dt. I write it. And I have cosine cube. So if I take one of them, I still have cosine square. And I also have 1 plus cube root of sine t inside the integral. So u is sine, so I have no problem with sine, but cosine, I don't need it. So I change it to sine. So this would be integral of 1 plus cube root of sine t times 1 minus sine square t, okay, times cosine t dt. Well, now I can change it to u easily. 1 plus cube root of u, 1 minus u square du. Well, I have two parentheses here, so let us expand. 1 times 1 is 1. 1 times negative u square is negative u square, plus cube root of u times 1 is u to the power 1 over 3, minus u to the power 2 plus 1 over 3 is 7 over 3. So that's it. You can continue easily, find the integral and change u to sine t, and you will get the answer. We have cosine cube but cosecant. So let me first write it as cosecant is the reciprocal of what? Of sine. So cosecant is 1 over sine. So actually, this is the integral of cosine 3 theta over sine to the power 5 theta d theta. You look to the numerator, not the denominator. You have cosine to the power 3 in the numerator. So you take u as sine theta. And du would be cosine theta d theta. Well, I need cosine cube. I need to write it as cosine square over sine to the power 5 and cosine square times cosine theta d theta. So this would be du. And sine would be u. Cosine square, I need to change it again to 1 minus sine square theta. And we are ready now to change the integral from theta to u. So it would be 1 minus u square over u to the power 5 times du. And you distribute the numerator over the numerator. 1 over u to the power 5 is u to the power negative 5. And u square over u5, subtract the powers. 2 minus 5 is negative 3 du. And I believe you can just add 1 to the power and then change u to sine theta. Well, we have cosine square and cotan. So what is cotan? So maybe if you have something else with sine and cosine, you need to change it to sine and cosine first. So we change it cosecant to sine. And what is cotan? I need to change it to cosine and sine. So cotan is cosine over sine. We should know this. Times cosine square. So this would be Cosine times cosine square is cosine cube over sine x dx. And this would be exactly the same question because we have here cosine cube over sine 5. So just instead of sine 5, I have sine. So I'll do the same steps, but instead of u to the power 5, it would be u. So the integral would be easier. So please continue this integral. Tan square. Well, what is tan? It is sine over cosine. So I have sine square x over cosine square x times cosine cube x. Well, I can cancel cosine cube with cosine square, and I will be left with what? 1 cosine in the numerator. Well, this is easy, okay, because you just take u as sine, and du would be cosine. So it would be u squared du, and you just continue and find the integral. Of course, you can say the power of cosine is odd, so you take u equals sine, or you see it immediately that it's easy to solve it by substitution. Sine square sine 2x. Well, I have to write sine 2x. Whenever you see sine 2x, it's 2 times sine x times cosine x. Immediately, you have to write it like this. So what would we have? 2, let me write it outside. Sine squared times sine is sine cube times cosine. So this integral exactly is like this one, sine squared cosine. But you have sine cube cosine. So you will take u equals sine and it would be u cube du. Exactly. All right. So please do it. Well, now we have tan and secant together. And for tan and secant, we have a relation tan square x plus 1 equals secant square x plus secant square x. And because of this identity, we can change tan square to secant square and secant square to tan square. So whenever we have tan times secant, we can solve the integral. If we have power of tan odd, if the power of tan odd, we can take u as secant. So if the power of tan is odd, take u as secant. And du would be the derivative of secant, which is secant tan. So I need to arrange this integral. Write secant tan here. All of this would be du. And tan is already taken, but secant cube, I took 1 secant, so I still have secant square x. So it would be u square du, and you continue. Let me continue this one because it's the first question about tan and secant. So it's u cube over 3 plus c. So it's 1 over 3 and u is secant plus c. That's it. Tan secant. Power of tan is not odd. If the power of secant is even, take u equals tan x. So d would be the derivative of tan, which is secant square x. So I need secant square x here and secant to the power 4, so I'll still have secant square and I also have tan square. But everything is theta, not x. All right. U is tan, so secant square, I do not need it. So tan square is okay, but secant square, I have to change it to tan square. So secant square is tan square plus 1. Times secant square d theta. And now you can change everything to u. So this would be u square times u square plus 1 du, and please expand and continue. Tan square. Well, the power of tan is not odd. So this is the third case. And the third case, if the power of tan is not odd and there is no secant with even power, so you have to think of something. Work. Okay? Work by your own. And here I think it's easy because if you write tan square as secant square x minus 1, because we said that tan square x plus 1 equals secant square x. So tan square would be secant square minus 1. We know the integral of secant square. What is the integral of secant square? Tan, because the derivative of tan is secant square. And what is the integral of 1x? And that's it. Tan square plus tan to the power 4. What to do with that? Let me take tan square as a common factor. Isn't it? It's a common factor. Let us see what would happen. I will have 1 plus tan square. Oh, but 1 plus tan square is what? Is secant square. Oh, so we have tan square secant square. Well, secant has power 2. We said if secant has power 2, I take u as tan. So du would be secant square. I have secant square x dx. So this integral would be tan square would be u square du. Wow. Continue. u 3 over 3 plus c. And what is u tan? So tan cube x over 3 plus c. That's the answer. Oh, I have tan and secant below. What can I do here? Well, let me write it. 1 over secant square minus tan square over secant square. Let me see what would happen. Well, what is 1 over secant square? Isn't it cosine square? Okay. And 1 over secant square is cosine square. And what is tan square? Isn't it sine square over cosine square? And this is 1 over secant, so it would be cosine square. These two cancels. Wow, and I have cosine square x minus sine square x. Well, you can change cosine square and sine square by the formulas we mentioned, 1 plus cosine 2x over 2. But in fact, this is an identity. Cosine 2x is just cosine square x minus sine square x. So if you know this identity, if you memorize this identity, you immediately notice that this is just cosine 2x. Wow, so the integral of cosine is sine over 2 plus c, that's it. Imagine this integral, the answer would be like this. That's nice. Wow, sine plus tan over cosine cube. What to do? Let me always do it like this. Sine theta over cosine cube. And then see what would happen. And this is tan theta. Let me write it like this. Okay, let me by now cosine cube theta d theta. All right. Well, sine over cosine cube, I cannot do a lot here, so I'll just leave it for now. But here tan, I can write it sine over cosine, and I already have 1 over cosine cube in the denominator. So this would be cosine 4. Oh, you just choose u as cosine. If I take u cosine, what would be du? The derivative of cosine, which is negative sine theta d theta. So I can write these as two integrals. Sine theta over cosine cube theta d theta plus sine theta over cosine 4 theta d theta. And then I use this one. I need minus, 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 minus. Let this be minus. So it would be negative. Negative sine theta d theta is du over u cube and du over u to the power 4. That's it. Of course, you write it negative u to the power negative 3 and u to the power negative 4. And then you find the integral. You add 1 to the power. And then you change it to cosine. So negative over negative, this is just a half. And u negative 2 will go down, would be cosine square. And this would be plus 3 down. And also u cube will come here. This would be the answer of this integral. You may find another way to solve it. Okay, try. What about this question? Well, look carefully. I have sine square, but I have 1 over t and t square here. And I know that the derivative of 1 over t is negative 1 over t square. So if I just multiply by a minus sign here and a minus sign outside, and I take u as 1 over t, then du would be negative 1 over t square dt. And then this integral would be negative integral sine square u. And negative 1 over t square dt would be du. So this would be the new integral. But to find the integral of sine square, we know what to do. We write it as cosine 1 minus 1 minus cosine 2u over 2 du. And the answer would be negative. I can take half outside this 2. And then the integral of 1 is u. Integral of cosine 2u is sine 2u over 2 plus c. So negative half u. But what is u? It is 1 over t. Minus half times minus half plus 1 over 4 sine 2u. But what is u? 1 over t. So that's the final answer. Negative 1 over 2t plus 1 over 4 sine 2 over t plus c. This is the last question. I hope you enjoyed exercises about this section.